Hello everyone, this again is the TPE November 2019 paper, Physics Paper 1, and we are now on question 4, which is a momentum question, and the question goes as follows. A bullet moves east at a velocity of 480 meters per second. It hits a wooden block that is fixed to the floor. The bullet takes 0.01 seconds to move through the stationary block and emerges from the block at a velocity of 80 meters per second east. See the diagram below. Ignore the effects of air friction and consider the block bullet system as an isolated system. So we have our fixed wooden block. We have the bullet going into the block. It's going in east. You can see they've given us some coordinates there so we can see which way is east, which way is west, north, south. Okay. It's going to go into the block. It's going to go through the block. Obviously, it's going to slow down when it's in the block, and then it's going to come out of the block at a velocity of 80 meters per second. Okay, so let's see what they want from us with this question. So first they ask us to explain what is meant by an isolated system as used in physics, because they said that this block bullet system is an isolated system. So what does that mean? Okay, this is learning now. Um, so the answer is an isolated system is a system on which the resultant or net external force is zero. Okay, so the net force on the system is zero. Yeah, so that's a learning question. So nothing else acts on it. The net force is zero. Okay. So now we go on to the actual questions. They tell us that the magnitude of the momentum of the bullet before it enters the block is 20 kilograms per meters per second. 20 kilograms meters per second minus 1. Okay. So then it asks us to for 3 marks to calculate the mass of the bullet. Okay, so what have we been given? We've been given the velocity of the bullet as it's going into the block, or over here as well, the velocity of the bullet as it is leaving the block, the time that it takes to move through the block, and then last but not least, we are given the momentum of the bullet before it enters the block. Okay. So we have the momentum, we have the two velocities, and we have the time. That is pretty much it. So if we look at what formula we have that involve momentum, we want it to involve momentum, we want it to maybe involve velocity, we want it to maybe involve time, and we want it definitely to involve mass because we're looking for the mass of the bullet. How much does the bullet weigh? Okay, not the weight of the bullet, the mass. Because weight involves gravity, we want mass. Okay, so this is 4.2.1. A really good uh formula that we find on the formula sheet is momentum equals mass times velocity. Okay. So we have momentum. It's the momentum of the bullet before it enters the block. We want to know what the mass of the bullet is. That's what we want to know. But we've got two velocities. We've got the velocity as it's going into the block, and we've got the velocity as it's coming out of the block. But now the question is, which velocity do we use? Okay, so the momentum is the momentum of the bullet before it enters the block. So the velocity that we must use is the velocity of the bullet before it enters the block. Okay, because the momentum of the bullet after it exits the block, when it is going 80 meters per second, is going to be different then the momentum before it enters the block. So we must make sure that they correlate to one another. Okay. So we were told that our momentum is 24 kilograms per meter, whatever that thingy is. We want to find out what the mass is, and we're given that the velocity before going into the block was here 480 meters per second. 480. Okay, now to find the mass, we go 24 divided by 480, and that is 0.05. Therefore, zero comma 0.05 kilograms. Do not forget the unit, please. Okay, nice. You can change it if you would like to grams, but there's a chance that we're going to need to use it in the next question. And mass is always in physics in kilograms. So if you were going to use mass in the next question, I'm gonna have to convert it back to kilograms anyways if you put it into grams. So you don't have to put it into grams, you can if you want to. Okay. And now the next question is asking us, what is the average net force exerted by the wooden block on the bullet? Okay, so what is the F net? Net force is the F net. Okay, so we are looking for the F net. We have the velocity before it goes into the block. We have that one. We've got the velocity after it comes out of the block. We have the time that it was in the block for. We have the mass. And we have the momentum that was before it entered the blocks. We have those things. We don't have the momentum afterwards. Don't have that one. Don't have it. Yeah. So that's all we have. So if we're looking for the F net, we've got the time, and we've got the mass, and we've got both of the velocities, then we're going to look at our formula sheet again for any clues. Okay. So you will see that the formula for impulse is F net times change in time is equal to mass times change in velocity. But mass times change in velocity is equal to the change in momentum. That's also in your formula sheet. And momentum is equal to mass times velocity. Okay, so the change in momentum is equal to the mass times the change velocity. So therefore, the momentum is equal to the mass times velocity. Okay. Now we can write this out nicely. F net, which is one that we're looking for, times the change in time is equal to the change in momentum. Okay. F net times the change in time is equal to, and then we know momentum is mass times velocity. The mass times the velocity initially, the change. So that's the final mass times velocity minus the initial mass times velocity, because the change is always the final minus initial. Okay. Speaking about this better first. The momentum of the bullet finally minus the momentum of the bullet initially. Okay. And that is what I was going to write just now. We also say that P equal to mv. That's how we get that from. This is a V minus mv initial. Okay. The change in time we were told. So the F net we're obviously looking for. The change in time we were told. The bullet takes 0.01 seconds to move through the stationary block. 0.01 seconds. So the time at which this net force is exerted is 0.01 seconds. 0.01 equals the mass of the bullet is the same for both, and work that out in the previous question. The mass of the bullet is 0.05 kilograms. If you had changed this to grams, you must remember to change it back to kilograms for this question because you can't have it in grams. 0.05 times. Now we're looking for the final velocity when it exits the block. The final velocity, 80 meters per second. Minus, okay, I told you that the mass stays the same. The bullet doesn't lose any of itself when it, when it travels through the block. Now we're looking for the initial velocity. Initial velocity before it went into the block. That is 480 meters per second. Okay, now we can work this out better. And we times this nicely. 0.05 times 80 is 4. And 0.05 times 480 is 24. And now we know that 0.01 times the F net is minus 20. So then F net is minus 20 over 0.01. And therefore the F net is negative 2000 newtons. Okay, now our resultant force can't be negative. You can't have done negative force. So what does this mean, the negative? What does this mean for this block? How is this net force acting that it's negative? Because that's right. This is right. It's not the final answer, but it's right. Okay. So the whole time in the system, everything we were told was happening eastwards. So in this system, just because of what happened, east was positive. East was positive. Okay, we can literally see on this compass, we're going this way, and that way is east. East is positive. So now if our net force is acting negatively, if east is positive, then the opposite of east is west. So west must be negative. So if the net force is acting against the direction that everything else was going, which was east, then the net force must be acting west. So we write here for our examiner, therefore, F net, the net force is 2000 newtons west. And you must put west in, you can't leave it as negative 2000 because we can't have a negative net force. But we do, but the net force is negative because it's acting in the opposite direction. Okay, so I hope this made sense. Please look at your formula sheet when you're not sure what's happening. Write down everything that you do have, tick off everything that you do have, um, and try to put different formula together like we did over here. We saw that we had quite a lot of this stuff in here, in this formula. Then we substituted everything in really nicely. Okay. So look for your formula, try and be creative with your formula. Just please look at the formula sheet and write something down because you will get marks for writing down a correct formula. Even if you don't get any further than that, write down your formula and you will figure something out. You will figure it out. Um, keep substituting in things into formulas and seeing which formula fits the right amount, fits the most amount of information that we were being given. Okay, thank you everyone. I'll see you next time for the next question, question 5.